in week 11 is all your notes for the structural section. Now I know some of the surveys are probably going to go and file it in file number 13, which is called the rubbish bin, but at the end of the day it's a full set of structural notes for you. At the end of it is the revision class, this one, and there is also the answers. But if you sit and stare at the wall right now for the next half an hour or so, you will not have a complete set of answers, you'll just get them modified. For example, and I'll go to the plate question. With the plate, I've pretty much just gone minimum, maximum, A, B, C, D, without any explanation on how I got the answers, okay? However, I'm going to put that on the board so you can work your way through that. Now, there won't be a chance for those that like to take photographs in movies. There won't be a chance of taking a photograph of it each time because I've got limited board space. I'm going to rub that out as well at some stage. You might be able to get a quick snap of it, but I would suggest the old-fashioned way. I know it's terrible, but there's a thing called a pen and a thing called a piece of paper, and you know it does work fairly well, even though it's what we did in the olden days. So yeah, the answers are there on this, but as I said, I don't really give an explanation on how I got to them, but I will do that for you guys. What's missing off this is the cross-section through the building, which I wanted to bring up first up. And even in discussions with David Poyner on moving this class forward in the future to a split for the structural with the surveying, he still wants some of the elements left in here, and he's got a very good reason for it. And he was telling me that the other day a house had been designed and it was the responsibility of the surveyor to position it properly on the property, and it turned out the surveyor hadn't quite understood some of the elements of the house, and the plans went in and council didn't approve where it was located. So they had to go back to the drawing board and completely redesign the house because of the survey. So he said that it doesn't hurt, it's not the end of the world, and it's pretty hard to not pick up some of these building terms if you're on site. So he wants me to include some of this in the notes as well. Probably not necessarily the reinforcing, but definitely this side of it. So what I've done in the test is these disappear, and instead of them, A, B, C, D, E, F, whatever, right the way around. And so I'll say to you, what letter is the bottom plate? And you'll go to bottom plate, and you'll hopefully have remembered that it was this to remember along here. And the old thing of the dwangs and the nogs, I think at one stage I asked which one is a dwang. There's actually a dwang and a nog, so there is two actual answers to that one. So you need to understand, there'll be at least two questions on this, guaranteed, and at least one question on the top one. So if you're going to do nothing else, at least study those two. Alright? Maybe put your own numbers or letters around there and block it out, and then see if you can regurgitate what it is. So on top of that, there are 9 multi-choice, but there's a few of the multi-choice calculations, so they're not necessarily all English this time around. If you were filming my lectures in the past, it'd be a very good idea to go back through and have a look at week 8, week 9, week 10, and highlight the bits that I've stopped and said there's a question, because it might narrow the field on what you actually have to study.
So week 8, week 9?
Week 8, week 9, week 10, yeah.
So it's this final exam not include the before part, yeah? Just
No.
from the 8.
No, because some people got 20, didn't they? So we don't want them to get 20 again. Okay. So, the plate. Have we got a data up? You good. So with plate design, and this might help you with your assignment as well a little bit. With plate design, the thing that I always tell students, and they always ignore me, is that it's a little bit like mum making a quilt, or grandma making a quilt in the olden days. She never used to sew around here. You never found her sewing around here. She always sewed around the outside. And in most cultures, wouldn't matter whether you were where you were in the world, if anyone was making some sort of a quilt which there's stuffing with something a bit warmer inside it, they tend to stitch around the outside. So if you think of that analogy, and let's apply it to bolt design, because there are more than one answer, but there's only one correct one for Moodle, and you want to get the correct answer, not just a random one that you thought of, okay? The priority is to push the bolts as far to the outside as possible. So looking at this one here, we've got 9 bolts. That's what the engineer's proposed. And he's saying that there's a 16mm bolt hole. Now that's a hole, not a 16mm bolt. The idea is to work out the minimum and the maximum. The minimum is equal to the bolt diameter times 2.5, and the maximum is equal to 32 times the thickness, or 300, whichever is the minimum. So, putting that into theory, if the bolt hole is 16, we always have 1mm right round the bolt. Now, strangely enough, when we're dealing with timber, we don't have 1mm. If it's a 16mm bolt, we drill a hole 16 mils, and even if it's a bit tight, we push it in with a hammer or whatever. It's a snug fit. With steel, we don't have that luxury. If you're out just a tiny little bit, the bolt will never fit into the steel. Okay? So we always allow 1mm right the way around. But if you've got one on that side, one there, one there, one there, that means it's 2mm that we have to subtract. So minimum equals not 16mm diameter bolt hole. So it equals 16 minus 2, which equals 14, times 2.5 equals 14 times 2.5, which equals 14 and 14 is 28, plus 7 is 35. So that minimum becomes the number we're going to push as close to the outside as we possibly can. So therefore, we start off by calling that 35 all the way around it.
So that means that it's if you got M16 bolts, that's the 16 is not bolt diameter, it's the whole diameter.
That, if it says 16mm diameter bolt hole, it's the whole of 16, so it's a 14mm bolt.
Okay.
It's not a particularly good example because I think it goes 16, 12, but I'm doing it in terms of how to work it out. So that's our minimum. Our maximum is the thickness. The thickness of this is 8, I think. Does it say that there?
Yeah,
8 millimetres thick. Thickness is 8 mils. So therefore our maximum equals 32 times 8, which equals 256. So that's our maximum, 256. Obviously that's less than 300. So it's 256. So what's left on this particular plate in terms of our 500 and our 400? 500 and 400. So what's left on the plate? 500 minus 35 equals 500, sorry, minus 70 equals 430, divided by 2 equals 215. Is that okay? Yes, it's less than our maximum, so that gets the big Nike tick. Working up the page, 35 on 400, it's going to be 400 minus 70, which equals 330, divided by 2 equals 165. Once again, that gets the big Nike tick. No problem. Looks confusing. Is probably one of the easiest examples of a plate that you're going to get.
Why 70, sir? I just
35.
35 and 35 each side.
okay.
Right. So in this particular case, we didn't have to do anything. We just did some maths and worked out what they were. And it's the same with the next example as well. With the next example, the only difference is it's a 10 mil thick plate. And to work out the maximum and the minimum, the 10 mil thick plate is 32 times 10, 320. So we drop that back to 300. Now you will get an example like the top one, and you will get an example like this one. In this case, the mathematics is exactly the same. The only thing to be aware of is that we're using 300 as our maximum. There's no breach of anything, so therefore the maths behind this one is exactly the same. However, the last one is the fun one. This one here. And I'll do that one on the board for you. I'll do it down here. Right here. So we have 1, 2, 3, 4. 1, 2, 3, 4. 710. 780. 10 millimetre thick plate. So it is 10 millimetres thick. And the bolt hole is 16 millimetre bolt hole. The minimum equals 14 times 2.5, which equals 35. So we've got 35 again. Our maximum equals 32 times 10, which equals 320. Wrong. 300. As I said before, when I first started, we go as close to the outside edge first. If you don't do that, you'll get this wrong. So let's go to the closest we can, which is 35. And let's put 35 in there. So therefore, the 780 minus 70 equals 710. There's two gaps, divided by 2 equals 355, isn't it? 355. So it's too big, exactly. We've got a problem. So we have to take it back to 300. So the 300 goes in here. Therefore, the 35 is going to have to change. 300, 300, that's 600. We're left with 180, so it's 90, right? So what we've done is we've pushed it, we've still pushed it as far as we can, but because of the 300, that's as far as we have to go right out to 90 and from the edge. There is a student from the degree said to me, well, why can't we just put more bolts in? And that is an answer, but that is up to the engineer who's designed it. Okay, when you've done subject like structures 2 or structures 3, you should be able to do simple bolt design on a plate. And the engineers decided that that's what they want, so that's what it is. Remember, you're costing the client more money every time you add more bolts and more bolt holes.
Question is why we don't about the middle the whole distance, the top one.
The top one?
Yeah,
Oh.
the middle one.
So why don't we put a bolt hole in there?
Yeah.
Well, sometimes they do, but generally speaking, the bolts go around there.
But that distance is bigger than maximum.
That distance between there and
Yeah.
there,
Yeah, bigger than maximum.
yeah, it's a bit like the assignment when you were talking about that as well. We do the we do the distances around the outside. We calculate it around the edge.
So
Right.
don't worry about the middle
No.
one. Yeah.
Often when it comes to this sort of thing, we have a situation where you have like a welded member on there, and there's no way of getting a hole in the inside of the plate. So let's do it back up the other way. In the other direction, when we go 35, 35, we end up with 710 minus 70, which equals 640, divided by 3, which equals 213.10.
213.
No, I've got 213.33. Yeah. So that's what that becomes 213.33, 213.33, 213.33, and that stays at 35 in that direction.
But on the corner one, you are moving to left.
This way it goes to 90. Yeah. Understand?
So the distance will be not the 213. I mean from the corner one.
From here to here is 35,
Yeah.
then 213, 213, 213, then
But
35.
the 91, you move to
This
the right.
one?
Yeah.
That, sorry, that, am I,
So directly the
it's 90 that direction.
oh,
Understand?
oh.
And 300, 300. Sorry, it's not very clear there.
One question, you got 213.33 during the test, once to as round up, are we using the engineering rounding, so become the 214?
You'll be using the engineering rounding, yes, but I think in the test it'll say 2 decimal places or 1 decimal place. Okay? If it doesn't, then ask me, put your hand up and ask, because it's not said what it is. Okay, I'm going to tell you something now which a lot of students don't remember, and a lot of students end up getting the wrong mark after doing the calculations. Plate design is in millimetres. Alright? Myrtle's got this funny habit of not marking you right if you put it in metres. So plate design is in millimetres. However, when it comes to scheduling plate, it's in metres. And we're going to get to that in the next example of what it's going to be like. So you're going to get about 3 plate questions in the test, of which I've nominated one as being quite easy and the other 2 as being a little bit more difficult, like that last one. It's not really hard, it's just a matter of learning those principles. So what I mean by you can have lots of answers but only one correct one, what if you were to make that say 100 and that 290, 290, 100? Technically there's no breach, but it is not the answer on okay? So you do need to apply that. See, they're getting a wee bit louder, aren't they? Never mind. I promise you I might burst into song.
Just going back to that one, you
Yep.
go, you've got 300 there, so you go straight to the maximum and then look out the fronts and the sides.
Yep. There is, and don't worry, I haven't got a question in the test like this, but if the 90 that you see on the sides ended up being more than 300, you would have to add another bolt. Quite simple.
Sorry, can you repeat?
If the 90 was, say, 310, then you breached completely, so you would have to add one more bolt. But I haven't gone that mean on you. I've actually had a couple of situations in real life design where that's happened. Engineers are not impressed when you go back to them and tell them, look, I'm just working out the design here and I think you've got it wrong. Just like I'm not impressed when you guys
The
do that.
maximum is 90, right? And then the minimum is
So
2,
that's
130.
the 90 distance. That means the vertical bar or the 90 degree to the edge.
minimum is 35.
No, because
The
35
corner right is
doesn't.
a horizontal distance
We
is
made
90.
it bigger because
So the vertical
it reached
all
the
the bar is
maximum.
90, yeah?
No,
Of
the vertical is
300.
Answer
35.
No, I
300
mean
or
the-
90?
Vertical, the other bar is
you
the
want all of
horizontal
the
distance
answers,
to
No,
the
I
edge,
can't remember.
all the 90, yeah?
Can you ask?
Yeah,
Ask him.
yeah,
Can you ask him, please?
90, and at the top here, 90 as well.
100.
So you're right, that goes 90, that goes 90,
All the
that
answers
goes,
around here, or is it just looking for 90?
and same on that side.
You do like line A or line B or line C.
The other thing is, you would have learnt from my first test that my figure numbers might be the same, but it's different numbers. So when you're sitting beside somebody with what you think is the same figure in the same question will have a different answer. So it's not worth peeping. You all know what happens to peeping toms, they get caught and they get locked up. So it's not worth it, apparently. All right, so I promised you'll get 2 or 3 of those plates. Myrtle's a funny thing. I don't want to say exactly because I've had students say I only got 2 and someone said I got 3. The way I've set the test up is you'll get a minimum of 2, put it that way. Right. The next one's the girder, which had a lot of people a little bit confused. If you understood this, the assignment steel was quite simple. If you were confused by this, it became a little bit more difficult. What happens here is that the plates are called up in millimetres, but the schedule is always in metres. Okay, so on this particular question, the call up for the TFCs, the UBs, the plates, the angles is always in millimetres. See that? 533 by 210, 122 UB. But down here in the table, it is always in metres. So with your answer, if it's say 980, put 0.980. Now, this is extremely typical of what you'll get in the test. What have I played with? I've played with this, that, and the angle. I've also played with the distance here, 12 metres. And if the beam is changed, some of these will change. If the beam's the same, they'll be the same. So it's pretty close to the same thing. Okay, it's the same sketch. I've just changed the call up for the members a little bit. So if you understand the way how to do it today, to me it's an easy 2 or 3 marks in the bank if you understand it. So how do we get these numbers down here? Well, I'll work my way through that. I'm going to rub out the left-hand section. So we'll move on. It's probably one of those courses that you need to that's not being cut because you can get a real job out of it. Sorry, I don't operate on that side of the brain. For other courses. All right. Remember, number off. If you're going to use that terminology in the final assignment, it's big N, you're allowed a little O, and then it's OFS. Okay? So that's one of the rare situations where you're allowed lowercase text on my drawings with a dot. Number off. Yeah. I would not mark you wrong if you did an uppercase O. Not that mean sometimes. Length and mass per metre. This is where some of you cocked up a little bit in the assignment 3. Some students put the mass per metre and the cubic mass per cubic metre as well, but when they did the multiplication, they multiplied these two into the equation, which was a bit of a mistake to make. Don't do that in this one. Total weight and thickness.
Mass meter.
What? Sorry. Yeah. Did we miss that? Okay. I'm looking over the other screen. I've got it beside me. I think I should be.
So you got length, then width. So after length, you've got width.
Yeah, I can see that. It's okay. I'm being put off by that. I'm mesmerised by that music next door. That's my excuse. Being drawn towards it, like the Hare Krishna tea.
اوس خبره کې 15 کیلو وزن کم کړم کنه
څنګه
سکواش کې یو منډي وهي بس وزن ډېر کم کړم.
Okay, well I would suggest that if you were lucky enough to get B as your question, Moodle's being quite nice to you at the beginning of the test. Or A for that matter. So what I've done is I've grouped some of these as easy questions. So within the grouping I've grouped some of these as very easy and some of these as quite hard and some of these as, you know, only for the student advocate end. So yeah, Moodle will pick some hard ones and some not so hard ones. Yeah. 300 TFC 46. Now, just reminded me something there. It's important to know what each one of these, how we call these up and why we call them up. For example, the fact that that's the weight of a member and that's the overall height. Because and there's a few multi-choice questions. I've said things like, in a plate that is 250 by 500 by 20, what does the 500 represent? Is it length or width, right? So that is a typical multi-choice question that is tied around this. So it's not just a case of remembering how to do this, but anyway, that's something that you also need to try and get your head around. So the number of, basically there is one of these universal beams going all the way through to the other end. There's one of these TFCs going through to the other end. TFC is another one which is a multi-choice question. Tapered flange channel. And I've said, what does TFC stand for? And I've given 3 multi-choice answers, and they're very, very similar to each other.
Tapered.
Forgotten.
Challenge.
Tapered flange channel. Flange. That's dead right. Well done. Okay, so 1, 1. There are 2 of these and 2 at the other end, so that's 4. And there are 2 plates, 1 here and 1 at the other end. So I won't change that. So if you're lucky enough to get B and C, you know, Moogle's being nice to you. So 1, 1, 4 and 2. The length is whatever the length is up here, and that I play with. So it won't always be 12. In this case, it's 12. The length of this is harder to calculate. You're going to have to do a calculation on that. So that I classed as a harder one. The length of the plate. Any ideas which is the length? 0.25 is the width, then it must be 0.5 is the length. And the thickness over here will be 0.02. They're actually quite good, those singers. Come to the conclusion. Didn't start off too good. Anyway, the thickness is something that some of you in your assignment forgot about altogether and just did the multiplications through here and forgot about multiplying by the thickness. So don't make that same mistake in the test. Now you use 7850 in assignment 3. It's a number, the actual weight of steel is somewhere between 7850 and 7860, and a lot of it depends on the batch that they make and like how pure the steel is or what it's been mixed with or whatever. In this one here, whatever I've got here, please use it. Don't just go back to 7850. So chances are it'll probably be 7860 or something like that. And the mass per metre here is another easy one in my mind. It's just these numbers under here, which some of you used in the assignment, which was the correct answer, would be 46. And 122. nothing on here, nothing on there, nothing on there, nothing on there, nothing here, nothing here. The mass per metre of the angle, now that was tricky, you had to work that out in the assignment, you don't have to do it for the test. The mass per metre for the angle is 14. If I use a different angle, it may be a different number. Right, so now it's a case of doing the totals, multiplying out the two totals, and so that times, if I do a little cross under them, you'll know what I'm talking about. That one times that one times that one
1464.
equals 552. Now notice I haven't done a decimal place on this, so let's call it two decimal places, naught. This one times that one times that one is 1464.00. And there is a calculation required for here, which I'm about to do. So looking at the beam, it's 533 UB 122. Now that 533 is the height, and it's also been called up, it's also got the width on it. The width on it is right there, 210. And there are two other factors that we need to take into consideration, and they're in the corner here, 21.3 and 12.8. 21.3 is that, and the 12.8 is the skinny part in the middle. Flange in the wheel. So using that and the fact that our angle has to fit in here, it is 533 minus 21.3 minus 21.3 equals 490.4, which gives 0.4904. Once again, it depends what Moodle's asked for. Two decimal places would be 0.49, wouldn't it? As far as the answer goes. So when we multiply that out, it is that by that by that. And of course, what a lot of you negated to do in the assignment is a total. This particular one does take a little while. I would suggest that this test will take closer to 40 minutes rather than some of you disappeared after about half an hour from the last one. And I would suggest that if you do get a couple of these easy ones, don't just sit there and go, "Oh, that was quick." Plenty of time now. Just have a little bit of a stretch and stare at the wall, because you will need a lot more time if somehow you end up with Ian. Okay. Yeah. Just out of interest, if we were to calculate the minimum width here, it would be that distance minus that divided by 2 would give us that width. But I haven't included that in the test, but I don't think.
So in the test, if your little asks for n and the rest is not filled, do you actually calculate all the rest and then calculate?
I've got it set up for student advocates and past students.
Roger.
You can actually form a group and do that, but I haven't looked into that. But I will.
If we ask to do L or K, then we have to find the whole thing, right?
Yeah, if you ask for L, you'll need to work out F and then do them that times that times that times that times that for L. Yeah. Yeah. So yeah, that's what I call a hard one.
Yeah.
But that's what I call an easy one. So that's why I said if you get that one, quickly put the one in and away you go, quickly work on the next one because you could well get one on the right hand side. Yep.
How did you get that 14 in the maths meters?
It's given to you and it will be given to you in the test. I'll show you where it is. Good question. It's up here. Okay. Yep. If anything, that's a bit blurry, unfortunately, this one, but if the test is a bit blurry, please just ask me and I'll tell you what the number is if you're struggling to read it. Okay, so you all get at least 2, maybe 3 of those. So, well worth going over that. Good thing is, you get a whole week for this to disappear out of your brain. No, that's not true. You get a whole week to learn this. So, please don't leave it till I come into the test, and I'm usually coming about 3 or 4 minutes late because, and I find that students are still flat out trying to read and work out what things are. You've got a whole week to do this, and at least the mathematical side of it. Okay, well this looks very familiar, doesn't it? This is the last of the revisions. And it is familiar because you've done the abutment. Next semester we won't be doing a bridge, we'll go back to doing some sort of building. The students will do a reasonably easy pad foundation design for reinforcing. In my opinion it's easier than this. And they will get a revision class that will look very much like this one, and they'll go, holy hell, what the heck, I've never seen an abutment before. What do you mean there's a Z bar? How does that work? Etc. So you have got, even although I made you go through the pain of assignment 3, you have got quite an advantage here in that when I go over this, all of you should know how to do it, really. And in the test, it will look exactly like that. All right. There will be different bars. So this might be a D20, for example, a 20mm bar, or a D12, or something like that. So don't expect the bars to be the same. There might be a different cover. It might be 50 or 30, or there'll be different lengths here. Your abutment was slightly different. No, you had 800, 600. I'm not sure. I think that might be very similar to the same size as your one. Okay, so this will change a little bit, and that's the sort of setup you'll see, and you'll get asked for T, or you get asked for Q, or you get asked for, well, it depends on who you are, whether you get asked for S. Okay, so you'll get a letter. Once again, I've done exactly the same, and I've figured out that, for example, 1606, working out that plus that and working out the number of those bars is quite a hard one. As per your assignment, quite a few got it wrong. So that would be classed as a hard one for 1606 in my book. And an easy one would be something like this straight bar that goes up here on either side, because that is just the length minus the cover at the top. So that'll be classed as an easy one. So you'll all get at least one easy one and at least one hard one, and then I just let Moodle do its thing. Alright, I think there's 3, maybe 4 questions here, so if you think about it, it really is, it should be a gift of 4 questions for you on this, because not only have you had the example
That's
of
an
the
immediate
retaining wall, you've also got the test model answer, and now I'm going to go over it step by step. And you're not allowed to ask questions on how high. There's two by there. Okay. So let's rip into it. So I have got answers here, but they don't cover it quite as extensively as perhaps I will when I work my way through it. If you want to do a quick photo of that, I'll do that now. I'm about to take that off the board
Still behind you.
because I need all the boardroom to work around.
Is that 20 questions?
Oh, you're filming it. Okay.
So yeah, there is. I think 20. Yeah.
Okay, as I stated before, 16.0, oh, maybe I should make it a little bit clearer. I get a lot of students who put their hand up when they first get this in the assignment and go, I can't work out where the bars are, what the lap is. It's exactly like your assignment, no different. So the first thing I'd like to draw is a picture of how it works. So this comes down here like that and round. This bar here comes and overlaps in behind and goes around like that. And these bars up the top here, they fall short and they go down to the abutment. Construction joint. And these ones here start at that point there. Just like the assignment. I know it's a wee bit rough, but at least you can see what they do. So these two bars here, this one and this one, we'll call them 01 and 02, are very easy to calculate. It's that distance there minus the cover at the top, and they do rest on the abutment. A lot of people got that 100% right in the assignment. I don't know whether you copied it or not, but the Hay Bros are going to have some trouble in this if they did. If they didn't, they worked it out themselves, well, this should be quite an easy gift mark there. So the answer to that would be 1,000, which is this height here, minus the cover, which is 40, making 960. The number of bars, well, this is the calculation that if you get wrong, unfortunately, you're going to get it wrong for all but one. So you're going to get it wrong for 01, 02, 03, 04, and 05. And I can tell you this much, in the test, it's going to come to 0.2 or 0.199. So please don't put your hand up, the past student won't help either, and say, I can't remember whether it was 0.99 up or 0.99 down, or was it 0.2? I'm going to do this for the last time. 0.2, it goes up. 0.199, it goes down. That is, and I'm going to put New Zealand there because the British standard is quite different. Yeah, 0.49 or 5? 0.49 and 0.5, yeah. You learned something?
Yeah.
I'm really pleased about that. Okay. If you come back to Unitec in 10 years' time and you see me, I might just be a skeleton on the desk or something. Remind me of that. I bet you can't remember. Okay, so in this case, to work out the bars, 3,700 minus the cover. So we're talking about the length and the length, or the width of the abutment, not the length, the width of the abutment. And that is given here. I changed that, so it won't always be 3,7. You guys had 3.1, didn't you? 3,100. Yeah. So 3,7 minus the cover, which is 40 and 40, makes 3,620 divided by the gaps, 250 centres, sorry, equals 14.48. Now that's an obvious one, it goes up, so that's 15 gaps, 16 bars. So 16 bars are these O1s and O2s, and they run in that direction. Now the cool thing about doing that calculation and getting it right, it's also how many bars there are for O1, O2, O3, O4 and O5. So that if you don't do anything, at least try and work out how to do that one. Change the numbers around and do it again. Do it with other numbers. All right? Because there's a very high chance, if you look at my A, B, C's and D's, you've just answered F, E, D, C and B. All right? So there's a very good chance if I've called that easy, that you'll get a couple from that row and they might be the same answer. Well, I'll do it a little bit out of order. Let's do A. And A is going to be equal to a wee bit of board calculation. So, working out A here. So to do A is the same way that it should have been done in the assignment. Should, yep. So we divide it into two rectangles. To do this top rectangle is quite different than the bottom rectangle, because this is lying this way and this is lying that way. Now in the perfect world it will be exactly the same, but it's not. So to calculate these ones, where they start and where they finish, and how many of them there are, it is 1,000 minus cover, and divided by 250, which is the spacing. And I've got the answer to that here. It is 920 divided by 250, which equals 3.8. So we go up, so that makes 4.
Yes.
And that's gaps, which equals 5. Now there are 5 that way, so there is also 5 that way. So let's make it 5 rather than something random. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so that's a total of 10. Now this way, the bar starts there and the bar starts here. If we zoom in on it, there's a curve, and the tangent point of the curve is where the bar starts. And I can tell the surveyors right now that if you don't like working out where the tangent is, you're going to have some problems when it comes to your second year of surveying, because you have to work out tangents horizontally. I know that for a fact. And I hated that in my surveying. Okay, so the tangent point there is our start point. And to work that out, we have the cover, we have a bar diameter, and that distance from the centre line there to the bar, this one here, is equal to 2 times the diameter. So you take that distance in from that end, and you do it from the other end as well. And so we end up with, this one's got a much better explanation of the answer. 1550 is the width, minus cover, that's that end and the other end. Distance to the start of the bar minus the distance to the start of the bar. Well, the distance to the start of the bar is going to be equal to 16 cover of 40 plus 16 plus 32. So that distance there is the same in from both ends, and you end up with that equation there divided by 250 equals 5.62, which equals 6 gaps, 7 bars. So there's 7 bars along here, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that makes 14. So 10 plus 14 equals 24. Sorry guys, in this case 24 is the correct answer for all those that put 24. Okay. I guess the only other 2 bars that provide a little bit of interest, we'll start with this one here, 1605. So when we do, when we put the numbers on the bars, it is always from outside to outside. So the outside dimension of that one is going to be equal to 14, the outside dimension of the bar, 1470, is going to be derived from 1550 minus 40 minus 40, which equals 1470. So if I was doing my little sketch over here, that would be 1470. From top to bottom of this piece, we've got the cover of 40, and we've got an overall height of, can't remember, 350 is it? 350, yep. So that's 350. So that ends up being 270, yeah. So that's 270. Now, the right-hand bend that we take off is usually given here, and in this case it says bend allowance 40 millimeters. You will be given that in the test. So that'll be 270 plus 270 plus 1470 minus bend allowance of 40 and minus the bend allowance of 40. And the overall answer to that ends up being, notice I'm saving the people at the front from the calculator, 1930. I did that one first because for those that weren't in any of my labs and they're wondering why their assignment wasn't right, the U-bar, all you do to the U-bar is you do that and you've got your Z-bar. And so therefore that's why we take our dimensions. So I didn't change the length of this in any way whatsoever. All I did was used strongman tactics and bent it back that way. Same length. Okay? So that's why when we do the Z-bar, the distances are from here to here, A, from there to the outside, B, and unusually from there to there is C. And there's an overlap, and that's me explaining the overlap. Best using pens, okay? If anyone wants to come to my office, I've got some reinforcing bars there, about 16 mils. You can try to bend it for me if you like and prove me wrong. So that's how we get our distances, and obviously the bend allowance will be 40 in each case. The hardest part about working this out is working out the overlap up the top there. So here's the bar here. That we'd have to work out. Now, the easiest way of explaining this is if we take that distance there, if we move it along 40, which is the cover, it's still going to be that same distance, but we haven't taken into account that bar width. So it's basically that distance plus the bar width gives us B. So that will be 512 cover plus, oh that's, I've got the ABCs around the wrong way, haven't I? So that's B. Oh no. No, that's B. And that's A. I did have it right. Okay, yeah I did. So B is going to be equal to 600 plus the diameter, which equals 616. A, 512. So how do we work out A? A is going to be equal to that lap, and the lap is given to you as 32 times the diameter. There it is there. Okay, if it's not given in the test, ask me and I'll tell you that. Although you should already know that, because that is one of the questions in the multi-choice. So A is 32 times, is 32 times the diameter there. 32 times the diameter, which equals 512. Yep. Plus, so it's 512 plus the cover plus the bar. So it's 512 plus the cover plus the bar. So 512 plus 40 plus 16 equals what? 568. And lastly C. C is quite easy. It's that distance minus cover, which equals 270.
So in the test, that's the 2 bar diameter all the same, right? It's because the lap is 22 by the bar diameter. If a different bar diameter, that's a
very good question. Very good question. I don't know if anyone heard that, or I know you guys didn't hear it. And I've done that in the test, so just be careful. Some of the questions, if you've got, okay, we'll use red and black. You've got a black bar, a red bar here, and you've got a black bar here. The red bar could be 12 diameter, that one might be 16 diameter. Which one do you take as being the lap? The 12 or the 16?
16.
No, he's right, the 16 one. Yeah, because we're designing in New Zealand and we don't want an earthquake to pull it down, so we go the highest we can. Alright? Another question. What about if that is a 12 millimeter bar and that one's 16 millimeters? Which one is the 2 diameters?
16.
Yeah, it's confusing, isn't it? It's this one here that we're bending. So whatever that one is, if that's 16, it's 16. If it's 12, it's 12.
16.
It's okay. If they're all 16s, that's fine. But if one's a 12 and one's a 16, it's confusing. So it's this one here that we take into account. You understand that? I hope whoever's friends with the guy that went out to the bathroom, perhaps they could tell him that. Big bit? Yeah, I know. When people disappear halfway through a lecture, I keep telling them it's not an exam. You don't have to go and find the answers. So that's 2 things to be aware of. One, that this chap here, very good question. Always take the biggest bar for the lap. And this one here, it's all very well writing out 2 times the diameter and remembering all that. but it's this bar we're talking about, not that one. And if you end up getting both of these bars as your hard question, you don't have to do the calculations twice. The distance here is 600 and 800. So there's only 200 difference between the two. So I won't do the maths again, because I haven't quite finished it, but you just basically add on 200. Yeah. So the maths behind this is 616 plus 568 plus 270 minus the bend allowance, and the bend allowance, which is minus 40, and the answer for that is 1574. So the answer for the 800 millimetre long one on the other side would be that 1574 plus 200 equals 1774 for the other one. Better just check that, and my maths is correct. Sorry, that one was 1374. I never got, and this one is 1574. See, even the lecture is not perfect sometimes. Okay, so I'm going to make that available for you all to have a look online, to research it. My scribbles on the board, they are quite important, so hopefully you've taken some of your own personal notes as well. I'll do that while I'm still here.